What's going on, guys? So if you've watched my channel for a while and another absolutely fantastic channel called AllAboutRVs, the host of that channel being Jared Gillis, if you've watched our channels, you have seen that both channels have dove headfirst into this whole sidewall to frame attachment fiasco that has really become loud in the entire industry. And part of this is based off of a video that I did, or several videos I did in Indiana with the folks over at Lippert, who produce the vast majority of RV frames on the market for both fifth wheels as well as travel trailers and several other different types of trailers that you probably would never expect. There were a lot of questions and concerns about those videos, about the content and what people said, specifically related to the structural elements of these RV frames, right? How thick the steel material is, how strong it is, what KPI or PSI the steel is, right? So we're going to talk about that, and we're going to talk about some experiments that we're going to do, some things that we think could possibly benefit the industry. And my friend Jared is actually going to chime in on his channel about some of this as well. So hang tight, I'll be right back. Okay, so you probably saw the video I released not too long ago where I showed you two components that were provided to me for this video. The first one is the main frame rail of the upper deck section of a fifth wheel. Now, this right here is a super heavy piece of steel, so much so that I'm using the mini excavator to actually put it in place so I can work with it. I have it strapped down on the other side, but this piece of steel probably weighs over 200 pounds. It is absolutely a chunk of steel, and it is super thick. So this is the wall thickness, which is about 1/4 inch thick. Now, if you've watched videos of frames from other manufacturers, let me tell you what I've learned. First of all, I've learned that sloppy welds exist across every single frame manufacturer I've seen. Every single one of them, when it comes to the areas where they're manually welded. When there's robotic welding taking place, yes, everything looks absolutely clean, but there's a lot of areas that are not robotically welded, and those areas almost universally across some, range of product line are going to have some sloppiness to them. The specific piece that I have here has been sitting out. It went through a tropical storm, and it has been out in the rain. And there is some surface rust in some areas, like right down here. There is a few areas on the end right here, but nothing significant. And this is salt air, so stuff that sits outside here that is raw and unprotected starts rusting very quickly. This piece of steel has been sitting out here for a while now, and this piece of steel is never exposed to the elements when it's part of an RV. So the powder coating that they put on it, in addition to the fact that it is built to be within the RV structure and covered up, you shouldn't ever deal with any type of rust issues. Plus the fact that it is super thick steel. So a lot of people reference other brands like New Horizon and brands like Arctic Fox who build their own frames. They manufacture their own, Northwood Manufacturing, a lot of these. And I've seen the YouTube videos of their frames. And yes, there are some elements that I like. There are some things that they do differently. But when it comes to the thickness of the steel, typically what you're going to see is either 1/4 inch, 3/16, or 9/64. That is what you see almost universally across everybody. In fifth wheel upper decks, it's usually going to be 3/16 or 1/4 inch. What you're looking at right here is 1/4 inch thick. This is very thick steel. So from a structural perspective, almost all of these manufacturers are getting their steel from SDI or a few other companies. You can actually see it stamped on the side of their frames, even if they're building their own frames. They typically are going to source it from the same domestic sources that Lippert or anybody else gets their steel from. What it comes down to at that point is the engineering, how much engineering goes into the structure. And again, even from that standpoint, you see a lot of similarities with frames. Like a Riverstone frame to me looks very similar to like a New Horizon frame. And I'm not going to say they're identical. I'm not going to say that you can say they're side-by-side matches of each other, but there's a lot of similarities between them. And when you go to these higher end luxury brands, they're all going to have very, very strong structural frames. Even if you don't go to one of those super high luxury brands that are super heavy, because that's typically why you see frames that are really, really overbuilt, you're still going to see frames that, for the most part, are never going to fail. But when we talk about issues that occur, one of the issues that Jared and I both focused on in our videos is this front section. So if you were looking at this as part of a fifth wheel, this would be the upper deck. The bedroom would be on the other side of this wall, or the living room, basically the overhang of the fifth wheel. Let me show you so you can specifically understand what we're talking about. So this is the upper deck area right here, right? That piece of steel that you saw is what runs right here, and it runs back to about this point, and then there's two upright risers that hold that in place. So you have this big, thick piece of steel that runs right here, and this is almost universal on all fifth wheels. Now, the sidewall that you saw would be the equivalent to this sidewall right here. So you have the sidewall, which is attached, and it's attached typically in two areas by three different types of materials. One of them would be your lag screws that go in from the inside of the RV, and this is where the controversy often comes into play, where people are like, I'm missing lag bolts, or they're loose and they've backed out. And to get to those, you have to be inside of the actual RV, looking in from the bedroom, basically, or whatever room is in this area. They typically cover it up with something. Sometimes it's carpeted, sometimes it's exposed wood, but you pull that stuff back and you will see a frame rail right there, and you'll see sometimes lag bolts going through. Sometimes you see no lag bolts, sometimes you see a few of them. But that's typically what you see from a fastening perspective from that aspect. The other fastening perspective are your vertical screws, and they're typically a wood style screw, very typical to what you might get from like Lowe's or Home Depot. And there's a lot of holes on this flange that come off of the bottom of that piece of steel, which we'll show you in a second, and those holes go into the bottom like this. Now those are usually completely full, which means there's no gaps. Every hole going up will have a screw in it, and that goes into the bottom of the sidewall right here. That flange is right here, and it's directly underneath the sidewall, and the sidewall rests on top of that. So you have screws going in from the bottom right here, and then some manufacturers go a step further and use like a Sikaflex or a construction adhesive material that has like a 500 psi bond strength. And basically what that does is that adheres the sidewall to the actual frame rail. So now that we know what we're talking about in the section we're talking about, let's take a look at what we have. Okay, so now that we're on the same page, sidewall of the RV, this is that long piece of steel that makes up your upper deck area, and the flange underneath it is this right here. Basically, it's welded to the bottom. It sticks out, and this one has a lot of holes. So let's count these holes. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 holes for screws that go up. Now, as far as I'm aware, most manufacturers put a screw in every hole. I could be wrong, but at least from what I've seen in videos that I've seen, and going back to tours that I've done, it appears as if every one of these holes is used. The big question for a lot of folks is, are all of these side holes used? And these were those screws I was telling you about. So envision this with me. You have the huge sidewall of your RV that's being brought to the frame, and they're setting it on top. This is just a section of it. Got to give a big shout out to my friends over at Alliance for sending this to me for this video, and Lippert for sending this to me. So they didn't even want to know what I was going to do with them. They just sent them because I asked for them. So the sidewall would be brought in, and of course this is just a piece of it. It'd be a huge sidewall. It'd be brought in with a hoist system, and it would be set down onto that flange and across the side frame of the fifth wheel going all the way back. So now that it's sitting on here, the attachment methods are a few ways. If you talk to folks at like Alliance and other companies that say they use an adhesive, they'll put an adhesive material in between here. And this is going to sandwich up against it, and you can see it sits very, very nice and tight. So that adhesive is going to hold that in place, and I'm sure it takes a little while to dry. So during that process is really where they're going to start putting lag bolts in right here. Now the lag bolts that they put in have to be a very specific length. Let me show you what we're dealing with. Now here's a couple examples of lag bolts that RV manufacturers use. They're basically a mild steel, nothing super special about them. And now what I don't know is if they pre-drill before they put these in, or if they just push it in hard enough that it penetrates through the aluminum. But they'll put these through like this. It goes through the frame, and then about that much of it, because you can see me moving the sidewall here, about that much of it, which is about 1 inch, is going to go into the sidewall. And then they'll fill all these holes with these lag bolts. Now right here is another example of a lag bolt that they use, and this would be used if it's a thinner sidewall, and if this material is thinner as well, because it's not going to penetrate nearly as deep. And again, this one would go in, and it would attach to this wall, thus pulling the two together. Now, in my opinion, if they're going to do this, it makes sense that they do this based off of the fact that they want the wall to pull against the frame rail, so the adhesive bond. So there's a tight bond right there. That's really the only scenario where I feel these side lag bolts make a lot of sense. Because, again, if these are simply going in to pull this piece tight up against the frame rail so the adhesive is sitting flat and it can make a really, really great bond, well, then it makes sense to put these in every single hole so that adhesive can sit. This can be bonded tight against it, and kind of like when you put glue on anything, right? You have to hold the two things together for a little while so that that bond works. And maybe that's specifically why these are here. But then that wouldn't explain why some manufacturers only use maybe 2 or 3 of these holes versus all of them. Now, how many holes are available to be used? 1, 2, 3, 4, 5, 6, 7, 8, and 8 holes. So you have 8 holes coming in from the side horizontally, and you have 14 holes coming in from the bottom vertically, going up. And I would imagine that if you are using adhesive in here, that yes, you should fill every one of these so you can make sure that that adhesive is going to have the tightest possible bond, and there's not a gap like that that forms. You want it to sit flush against the side. That said, though, I don't know if this type of fastener is the best type of fastener for this application. Now, let's look at this sidewall component that was sent to me by the folks over at Alliance. This actually is very unique. This is different than what I've seen in virtually every fifth wheel that's being used on the road. And let me explain to you what I'm talking about. So typically, and I'll try to find a picture that I can overlay, the sidewall right here is a piece like this. Then you have a larger opening right here that's hollow, and then a piece of wood on top of it that's like this. So you have 2 pieces of wood like this, and then you have a big opening right here between them. And the theory here, or at least the mechanics here, are that when they put the vertical screws in from the bottom, they'll go through this piece of aluminum, they'll bite into this piece of wood, and possibly even go through this piece of aluminum, and this piece of aluminum essentially acts as kind of like a lock nut on the other end of it, because when you drill through aluminum, the aluminum is soft enough, so in some ways that just drilling into aluminum itself can act as kind of a locking fastener. When you go in from the side, if they're using a piece of wood like this up here, depending on where these holes are, if the hole's up higher, and that's all, I guess, part of the spec whenever you spec your frame out with Lippert, then you could be going into that piece of wood up top. And I think that's probably what they expect. With this specific setup, this specific frame rail, and this sidewall, this is kind of set up perfectly for the way that they've redesigned theirs at Alliance. So the way this one's going to work now is when the screw goes through here, it's going to go in. Of course, this is all a hollow chamber, and that's the reason why these horizontal lag bolts, in my opinion, just don't do what I think they want them to do, aside from, again, just pulling this tight if there's adhesive in here. But when it goes through, it's going to go through the Asdel on the inner wall, through the aluminum right there, into the piece of wood, and if it's long enough, which this one might not be, it would probably have to be about a 1/2 inch longer, it'll go through this piece of aluminum right here. Now, this specific lag bolt is actually made for fifth wheels that have a slightly thinner sidewall. The sidewall right here is a little thicker than what a lot of RVs come with. So it's going to go into the wood, and it could penetrate back through this piece of aluminum. Again, I do not know if they pre-drill this, and we might just try to drill this through just to see what happens. From the bottom, the lag bolt goes in from the bottom, or the screw. It's more of like a wood screw, according to what Jared showed me and what he saw. And in my opinion, it's just not a really strong fastener. I wouldn't trust that fastener to be able to hold the forces at play when this sidewall wants to move like this on top of that frame rail. They don't appear to be structurally sound enough to be able to hold the type of weight that they're expecting and the type of energy in different directions. So what would I suggest? Let me show you. So my suggestion, if you want the ultimate strength and you don't want any chance of real detachment, is to go to actual bolts. Run bolts all the way through. If you look at what Riverstone does, they actually bolt all the way through into their sidewall, through the frame, and then they use washers and nuts to hold it in place. that is the best way to do it. But the reason why they can do it that way, and a lot of manufacturers don't really have that luxury, is because of the type of sidewall that they use. It's a hung sidewall, which means it's hollow inside until they put the insulation in. If you look at the top of this segment right here, you'll see that it's filled with foam. So this entire wall is laminated, filled with foam, and to get to the area where you would want the bolt to actually catch, which would be on the aluminum, would mean that you would have to create some type of a hole or cavity in this sidewall material for the bolt to be able to go in, so it's not actually fastening to the asdel material and sandwiching that versus the aluminum. Because the way you would want it to seat up against the aluminum and not up against the asdel. So your pulling force wouldn't be on a material that's compressible. It would be on aluminum right here, and possibly even going through the wood, through the frame like that, and then bolted on the inside. That would pretty much ensure, or at least greatly reduce, the chance that you're going to have any type of disconnection occurring between the sidewall and the upper deck frame area. But I do think that there's other possible ways of doing this and other ways of addressing this that could work almost as good, but not quite. And let me show you what those are. So another method of attachment could be using structural screws as your fastener. So instead of using your traditional wood style screw going in from the bottom, which the pull force on a screw like that before it actually breaks is going to be much, much, much lower than using an actual structural screw, which is actually designed for both shear force and pull force. These right here have a tremendous amount of holding force before it actually breaks. And you could use these both probably in replacement for your side lags to keep the wall fastened to the side so your adhesive can cure. But it probably, even if you're not using it for that purpose, something like this is probably going to work a lot better overall than going with a lag bolt or your traditional lag bolt. Again, these are structural screws. They're available in all sorts of different lengths and flavors. But the reality is using this versus a traditional wood screw going up from the bottom, I really believe would be a huge step forward in terms of holding power and the ability for this to truly secure the sidewall in place and just prevent it from moving at all. I mean, this is right here a far better, more expensive solution than a wood screw. Another idea I have is to work with like a plate. So how would a plate work? Basically, if you had a plate like this, as an example, but a much longer one, and it had a threaded rod sticking out from it. A threaded rod would be kind of like a bolt. And you pre-drilled your holes on this side, and they go through to match maybe the holes that are already here on this side. And the bolt plate goes like this, but it has a threaded rod coming off of it that goes all the way through, and you can fasten it to the other side. And the plate itself is what distributes that energy across a much wider area. That would probably be the best possible way of constructing the sidewall. It would take a lot of the load energy off of that real thin aluminum piece here. It would transfer it to a much thicker piece. The downside to this is you'd probably have to put some type of trim to cover that up on the outside, because you'll see it. You'll see it on the outside of the wall. And even at that point, you could probably expect that if the plate was mounted outside of the sidewall material, because it's spreading that load out over a much larger area, you could probably just have it clamped directly to the sidewall material. I don't think, and I don't know specifically to be sure, but I don't think that you should have much of an issue with the material compressing, especially if you have it spread out over a much larger area. But imagine a plate that is the length of this area where your lag bolt holes are right here, with a bolt that's welded to it that goes through, comes out this side, and then you bolt it in place with a nut and a lock washer. You do something like that, this wall will probably never move. It could move a little bit, but it's never, in my opinion at least, based off of what I'm guessing, going to detach from this section right here. Plus the use of structural screws coming in vertically from the bottom, that, in my opinion, 14 of them running across the bottom structural screws with bolts going all the way through, that to me seems like the best possible practice for this type of attachment method. But what I'm going to do now is I'm going to take some of my structural screws, I'm going to run them up from the bottom, and I'm going to see first and foremost if I can get through the aluminum without pre-drilling, and if I can, how far can I get into it. I love the fact that it has kind of like a washer already built into it on the end. Love that. Now, one thing I'm noticing here is I wouldn't really want to put these in until I have the side lag bolts in, because this could move slightly. This could shift away a little bit, and then you're definitely going to have a gap right here. So I definitely can see the perk of having these side bolts in place to hold the sidewall in place at least until you get the bottom screws in. So that in itself is a good enough reason to be sure that you have side lag bolts in place. So let's go ahead and do that first. So now I'm going to install these 3 and 1/8 inch industrial fasteners. These are structural fasteners. Okay, so I've put 3 of these in. You can see how far they'll go. They're going to go through the 2-inch section of steel here, which is already pre-drilled out. Then I pre-drilled the hole. It's going to go through the Asdel, through the aluminum sidewall right here. Then it's going to go through the wood, and then partly through the second piece as well. It's really not going to go through there. If I had one that was maybe a 1/2 inch longer, you'd get more bite, but the pre-drill itself is probably bigger than the teeth that are going to catch on it. But with the 3 in place, I'm going to be honest with you, it is pretty dang tight against the sidewall here. Look, I'm going to show you this gap right here, and you can't see it getting any wider or narrower based on me moving that. So the whole actual beam is moving when I do that. So yes, this is structural right now because it's a static load. It's not moving anywhere. If it was dynamic going up and down the road, just the gap between the screw and that opening right there, if you see that, and how far it has to pass through before it gets to another hole which has an equal gap, which is going to allow the screw to move like this, would mean that there's always going to be movement here. Up and down movement, you probably won't see it here because they're relatively tight right now, but if I move this up and down, these screws will be able to move up and down. There's absolutely no way that the type of force at play here is going to prevent that from happening, because right now I'm using compression, right? I'm using force that's squeezing the two together. I'm not using any type of shear force really to prevent this thing from moving up and down. In order for that to occur, I have to put the screws in from the bottom right here. So let's go ahead and pre-drill that out and get the screws in place there. These screws should feed up to right about here when we factor in the flange. But one thing I want to keep in mind here, though, is that, again, if the purpose of these are to add a little bit of rigidity, I get it. But if the main purpose is to squeeze this sidewall up against this upper rail for the purpose of being able to put the screws in the bottom and have this completely flush against the sidewall of that steel channel, makes a lot more sense to me. That absolutely makes more sense to me to do it that way versus trying to not put screws in here and hold this in place until you add all the lag bolts from the bottom. But let's go ahead and put some structural screws in from the bottom as well and really see how strong this attachment is. Okay, so we have all of our horizontal screws in place. These are all structural screws. And now we have, I didn't fill them all, but we have what, 5? We have 10 structural screws coming in vertically from the bottom. And I don't know if you could tell on the video, but when I tightened these, it actually bent the flange slightly up. The compression force Actually, you could see where the specific areas where the screws were bent up to stay in place, which means there's a lot of grabbing force in here. It's going through, let me show you here. It's going through that aluminum channel, through the piece of wood, through a second aluminum channel, up into this piece of wood, and it's probably not going directly in. It is probably squeezing between this piece of wood and this piece of aluminum right here, because you can kind of see how the screws are aligned right here, and they definitely go more towards this area. So pre-drilling probably helped, but this sidewall it's on there. And if you're doing that on both sides, again, these are definitely going to keep the wall compressed side to side. The bottom ones going vertically up are going to keep it from moving up and down like this. So these will play a factor when everything's said and done, because these shouldn't technically be moving up and down very much if this piece is secured to that flange properly. And I think that's probably where some of the issues come from, is that the screws that they're currently using, a lot of the RV manufacturing companies are using, probably don't have the shear strength to prevent the top, not really shear strength, but the lifting force to prevent that right there, the pulling power, from breaking off the head of the screw. Once the heads of these screws down here break off, or if they back out or become loose, then these side lags are going to start moving up and down in their holes. And again, you might be able to see through the tube here. Let's see if I can get a good shot of that. It's probably going to be hard to see, but you can see the screws going through, and those screws right there are going to move. If this sidewall can go up and down, there's nothing preventing these from slightly moving up and down, and eventually they're going to do this number, and they're going to wallow themselves out, and they will back out. So the biggest thing I think the RV industry needs to adopt is the use of a stronger fastener coming in from the bottom, and a method to keep the screw secured once it goes all the way through. Right now, this is a really good method, I think. Switching to a fastener like this, again, a much more expensive fastener, going in from the bottom like that, and making sure that it's biting into as much material as possible so it secures this sidewall down, is really going to be what's needed. You know, when you factor in the attachment method here, coupled with how the entire sidewall is attached and the roof structure and the front cap, I can definitely see how this can become very, very, very structural very quickly. So to kind of sum up what I think needs to happen here is, I think the RV manufacturers need to follow Alliance's path in making this piece right here of the sidewall better. If they can make this part of the sidewall better to where whenever you attach from the bottom, it's going in a fashion that's going to create the most friction, the most force, and the most clamping power, I really think that's what I'm seeing, at least in my opinion, is going to be the best opportunity to make this part better and attach the sidewall to the frame structure in a more permanent, better way with the least amount of possible detachment and movement. And when you have this fastened well from the bottom and this isn't going to move, then these lag bolts will certainly help, because they will compress these two pieces horizontally together. The problem is once you start getting any detachment from the bottom or movement from the bottom, and this sidewall starts shifting up and down, there's nothing to prevent these from moving, and once they start moving, they're going to work their way out. And this is what I think most people are seeing when they see a sidewall detachment issue. So again, my opinion, proper attachment from the side to compress a really high quality construction adhesive from the inner material here, using a material like this, which is Asdel on the inside and outside, which isn't going to rot like, you know, Luan can and other interior backers. So the adhesive right here with the bolts, compressing it together, and then as many of the bolts coming in from the bottom as possible. These construction screws are fantastic, and they're built so well, and quite frankly, they're going to have a tremendous amount of holding power and fastening power versus a wood screw or something like that. And the good thing is you can kind of use the same ones in different areas. But in my opinion, that sidewall is attached very, very, very securely to this frame now, in my opinion, based on what I'm seeing. And even without it, connecting it like this, thanks to how Alliance has redesigned, this is probably going to be far less susceptible to any type of detachment. But what do you guys think? I know this is a pretty lengthy video, but I definitely wanted to be pretty comprehensive in terms of my opinion, what I see, and the value of both your horizontal screws as well as your vertical screws, what part they play, and even what a construction adhesive might play. In my opinion, though, I don't think it's really a steel problem. The steel is strong. You see very, very few actual structural failures of the frame section of RVs. You really do. If anything, it's typically what's attached to that frame that starts to fail. And I think really honing in how you're doing this piece right here, this part right here, and what you're doing to ensure things aren't breaking, aren't shearing off, is probably the most important aspect of all of this. And if the frame starts to fail because of that connection method, well, then that's always something else we can look at and explore. But I don't think that's what's happening in the vast majority of cases. Anyways, guys, I would love your feedback. Please leave a comment below. If you haven't had a chance, please take a moment, subscribe to the channel, give me a thumbs up, and we'll talk to you again very soon.